Hello, you wonderful people taking math. My name is Brian Hutchison. I am a professor here at Victoria College, and today we're going to talk about some triangles, right? And applications using triangles. So, there is a math dedicated to just triangles. Y'all know it as trig. But a lot of other math classes deal with some of the applications. They don't quite go in depth as trig does, but we can make them all work out still. So let's say you were right here. And let's say way over here was a plane. And let's say you had one of those fancy gizmos that can tell you how far away something is, laser range detector. But you learn that this plane is, let's say, 4,580 feet away from you. And then we can finish up our right triangle. And my question to you is there any way that we can understand or know how high this plane is flying? Well, I need some more information. So let's say that you can measure this angle of elevation, and you find it to be 30 degrees. So now we really have two pieces of information. We have how far you and the plane are from each other, and the angle of elevation, basically the amount that you measured from the horizon upwards to the plane. So, how would we find how high that plane is going? Well, you got to remember from the previous videos about the ratios and how everything wants to stay in proportion, etc., etc. But from the 30-degree angle, this guy is known as the opposite, and of course this one is known as the hypotenuse. Opposite over hypotenuse is OH, which is sine, SOHCAHTOA. So if I take the sine of 30 degrees, and I'm just going to, instead of using a question mark, I'm going to call that x. All right, it's opposite over my hypotenuse. Well, if I'm going to solve for x, well, I need to get rid of the division by 4,580. Well, the best thing we can do is multiply both sides by 4,580. Period. Well, that's not a period, it's more of a multiplication dot, but in the end, this cancels, so 4,580 sine of 30 degrees is equal to my x. So some of y'all have some dang good calculators, and you really have no problem typing this in. You have no problem typing this in. 4,580 times sine of 30. You just got to make dang sure that your calculator is in degrees. Some of y'all don't. All right? So if you do not have a calculator that allows you to type it exactly like you see it, right, so this would tell me that x is equal to 2,290 feet. That's how far up this plane is flying off of the ground. Well, if you have a calculator that will not do, and the problem is the sine of 30 degrees. Some of your calculators, right, you have to put in 30, right, then hit the sine button, and I always like to hit equals after this, and it'll tell you what sine of 30 is. It's a very neat little number. And then multiply, right, by 4,580. In this order. Could you have multiplied by 4,580 first? Most definitely. But I like to get rid of the harder part first. I don't know. It's just sometimes some calculators do not behave nicely with sine, cosine, and a tangent. You just have to put in your 30, then hit your sine. But this is where I'm hoping most of y'all are at. The hardest trick we ever see with these is usually drawing the picture, right? Converting your words over to a picture. And then second is, well, what do I use? Sine, cosine, or tan? That's depending on your picture, right? Look what's opposite of your degree. If that's what you're looking for, you're going to need opposite over, and if they give you your hypotenuse, well, you're using sine. If not, you're going to use opposite over adjacent, which is your tangent. So one more problem, probably one of my favorite problems, is you are in a building, right? You're not on the ground floor. You know that straight across 200 feet away is a bigger building. You know your angle, and going up, the angle of elevation is, let's do 40 degrees. And let's say the angle, see, my middle name is not Picasso, folks. This angle going down is 50 degrees. So my question is, how tall is this building? Well, I see two triangles. If I can find what's opposite of the 40 degree and opposite of the 50 degree angles, A and B respectively, if I add A and B up, I can get the total height of the building. So notice what we have. We have the opposite of the angle 40, and we have the adjacent being 200. That's tangent. So the tangent of 40 degrees is A over 200. Even though it's upside down, these things are still right triangles, and the tangent of 50 degrees has to be what? The opposite over the adjacent, which is also 200. So on these, once you have this down, they solve very, very similarly. The 200s cross, which tells me one part of my height is 200 times the tangent of 40 degrees, and the other part of my height is 200 tangent of 50 degrees. So once again, if your calculator's nice to you, you can put this in pretty much straightforward. Pretty much straightforward. If not, you might have to hit 40, then the tangent, and then times 200, and then do 50 for the other one. Well, what did you get? You got a really ugly number, right? So on a lot of these, remember it's a ratio which is related to a fraction. Sometimes you're not going to get pretty answers like we did at the beginning. You're not going to get pretty answers like you did at the beginning. But be careful with your rounding. If it says round to the nearest tenth of a foot, you don't round until the very, very end. Right? In fact, we can even make this guy as 200 tan of 40 plus 200 tan of 50. And just let the calculator deal with all these big numbers. Let the calculator deal with all these big numbers. But adding A plus B together gets me to 406.1706447 some change. If I want to round to the nearest tenth, I look at the 7. The 7's bigger, which rounds the 1 up to a 2. Right? It's bigger than or equal to 5, and you round up. So this is 406.2 feet. This is the height of the building next door to yours. Have a good day, folks.